Distinguished colleagues, good afternoon. It's September 23rd, 2021, 2 p.m. Moscow time. And we are about to start the panel session for the defense of the doctoral thesis by Andrey Koval. But unfortunately, we have a technical break. Professor Christoph, did you hear? This channel? Please let us know if you do. Christoph, do you hear us? Do you hear the English channel? Christoph, do you hear the English channel?
Yes, I can hear you.
Christopher, do you hear the English channel right now? Professor Jacobi, do you hear the English channel right now? Да, правильно. Он слышит зал. Christoph, do you hear the English channel right now?
I just hear you talking. Is this okay?
Okay. Okay.
Да, слышу вас.
So I believe it's okay. We're about to end our technical break. So we beg your pardon for the sound problems. We could not fine-tune the channels because there are too many of participants today and the situation is quite complicated. Now we're waiting for other participants and we start our session. Just a few moments.
Она мне даже по блату сделала 40% скидку. Она мне сделала специально на мою пирожное машине. Нет, она молодец. Продавец. То есть я ее беру, я говорю, у вас есть скидки?
Не надо.
Она говорит, для вас есть.
Она мне тоже.
Но она мне делает скидки. Нет, там ничего. Вот это, например, смотрите, как поставить водичку надо принести, а мне надо.
Объясните.
Тут ничего нет особенного.
Dear colleagues, just a few moments. We're about to continue. Это английский канал. Вы слушаете английский канал?
Слышу на русском ваш голос.
Иван Викторович, вы слышите Наталью или Фаину? По-моему, никого не слышит. Distinguished colleagues, 2 more minutes. We are waiting for one of the members of the board. I beg your pardon for that. Yes, unfortunately he could not get connected, and we wanted to get his full participation as well.
Understand.
Английский канал, проверка. So, Ivan Viktorovich, we're happy to see you. Do you hear us and do you see us?
Sorry, my
Professor Karpov?
Да, я слышу, всех слышу. Извините, коллеги, за такой вот наклад.
So, dear colleagues, I beg your pardon for such a delay. Yes, I do hear you, I see you, so we're finally ready to start a final checkup. The broadcast is on. Okay, we can start. So, dear colleagues, we continue our session after the end of technical break number 1. So, we're beginning the panel session for the defense of the doctoral thesis by Andrey Koval. The thesis is submitted for the academic degree of Doctor of Sciences in Physics and Mathematics. The specialization is Atmosphere Physics and Hydrosphere Physics. The title of the thesis is Interaction and Effects of Hydrodynamic Waves in the Middle and Upper Atmosphere. Under the order issued by the Academic Secretary of St. Petersburg State University as of April 5th, 2021, I, Evgeny Mikhailov, Doctor of Sciences in Physics and Mathematics, head of the Atmospheric Physics Department of St. Petersburg State University, was appointed the chairperson of this dissertation board. The order also approved the candidacies of the members of our board, and let me introduce them. Vladimir Kostov, Doctor of Sciences in Physics and Mathematics, a leading researcher of the Atmospheric Physics Department of St. Petersburg State University. Alexander Polyakov, Doctor of Sciences in Physics and Mathematics, Professor of the Atmospheric Physics Department of St. Petersburg State University. The following members of the board are working remotely. Yuri Timofeyev, Doctor of Sciences in Physics and Mathematics, Professor of the Atmospheric Physics Department of St. Petersburg State University. Yuri, can you hear and see us? Yuri, please answer.
Yes, I hear you. Я вас слышу. Все нормально.
Ivan Karpov, Doctor of Sciences in Physics and Mathematics, Director of the Kaliningrad branch of Izmiran.
Я все слышу, все в порядке.
Yes, I do hear you. Everything is okay. Alexei Krivolodsky, Doctor of Sciences in Physics and Mathematics, Head of the Laboratory of Atmospheric Chemistry and Dynamics of the Central Aerological Observatory of Roshydromet. Alexei Alexandrovich, do you hear us and see us? Alexei, please answer and turn on your microphone. Yes, your microphone is on off.
I'm here. Here I am.
Nikolai Pertsev, Doctor of Sciences in Physics and Mathematics, leading researcher at Obukhov Institute of Atmospheric Physics, Russian Academy of Sciences. Nikolai Nikolaevich, can you see and hear us?
Yes, I see you okay.
Distinguished colleagues.
And see and hear. Вижу и слышу хорошо.
Коллеги, вы английский слышите или русский? Или оба?
И тот, и другой.
Да, и тот, и другой.
Слышим.
Sergei Soldatenko, Doctor of Sciences in Physics and Mathematics, Professor Deputy Director of the Main Center for Information Technologies and Meteorological Service of the Federal Hydrometeorology and Environmental Monitoring Service. Sergei,
я здесь, да, я здесь. I'm listening to you. Thank you very much.
And Professor Christoph Jacobi, Doctor Habilitatus, Professor of Leipzig University, Germany. Professor, can you hear and see us?
Can hear you. Thank you and see you. Thank you very much.
And we have our candidate for the degree, Andrey Koval. And we also have the academic advisor, Nikolai Gavrilov, Doctor of Sciences in Physics and Mathematics, Professor of the Atmospheric Physics Department of St. Petersburg State University. Distinguished colleagues, I would like to inform you that the panel session of our dissertation board is being recorded and broadcast on the St. Petersburg State University website. And it is also interpreted from Russian into English and vice versa. Currently, we have an email address posted on the page with live broadcast of the board session, and all listeners can submit their questions to Mr. Koval online, the questions regarding the thesis or scientific discussion. These questions will be forwarded to me by our technical service, and I will read them out during the discussion. The questions must be related to the thesis and the presentation, and do not forget to give your name, surname, and position if you submit a question.
Recording stopped.
Under the order on the procedure of granting academic degrees at St. Petersburg State University, approved by local normative acts, the session of the dissertation board is valid, providing 2/3 of the appointed board members are present. Our board consists of 9 people. Everyone is with us today, including 6 members of the board who are working remotely. We have a multimedia connection with all the members of the board as well as with our candidate for the degree. Therefore, we have a quorum. And our session should not last more than 3 hours, and the agenda is as follows. First comes the chairman's presentation about the documents submitted by the candidate for the degree and their conformity with the requirements. Then the candidate's presentation, providing an overview and the findings of the research, 20 minutes for that. Then questions to the candidate regarding the presentation, no more than 2 minutes per question. Then the candidate's replies to the questions, 10 minutes for all the questions. Then the reports on the thesis. The board members will be taking the floor in turns to provide their reviews and questions. Ten minutes per speaker. Then the chairman's report on the thesis, 10 minutes for that. Then the candidate's comments about the reports on the thesis and replies to the questions, 20 minutes for that. Then we're going to have open discussion. Anyone present at the defense may state their position or ask specific questions on the topic. 2 minutes per question. And I kindly ask you to fill in the registration form and introduce yourself before I give you the floor. Then, the chairman will ask the questions submitted during the broadcast via our website. Next, next come the candidate's replies to these questions. Then we're going to have the presentation of the academic consultant. Then we may have a 5-minute discussion before the open balloting on conferring or non-conferring the academic degree. The discussion of the results of the defense is not broadcast. Then we're going to have open balloting, vote counting, and recording the results in the protocol. Then we're going to make a decision on whether to confer the academic degree or not. And finally, we're going to listen to the candidate's closing speech, no more than 2 minutes for that. Dear colleagues, any questions or comments on our agenda? The question is whether we should hear the English channel or the Russian channel. The text will be delivered in the Russian language. We can't hear. We have a mix of languages, both Russian and English. So, the short chairman's presentation. The doctoral thesis by Andrey Koval for the academic degree of Doctor of Sciences in Physics and Mathematics, specialization 250029, Atmosphere and Hydrosphere Physics, is titled Interactions and Effects of Hydrodynamic Waves in the Middle and Upper Atmosphere. The thesis was approved for the defense by the order of the Academic Secretary of St. Petersburg State University, issued March 13th, 2021. Mr. Koval has prepared his thesis at St. Petersburg State University, and Nikolai Gavrilov, a Doctor of Sciences in Physics and Mathematics, Professor of the Atmospheric Physics Department of St. Petersburg State University, is the academic advisor. 33 published articles describe the research findings. They include 4 articles published in peer-reviewed journals recommended by the Ministry of Education and Science of the Russian Federation, and 20 articles published in journals indexed in Web of Science and Scopus. The candidate has submitted the full set of documents to the academic secretary. The above-mentioned documents comply with Item 12 of Section 3 of the Order on the Procedure of Granting Academic Degrees at St. Petersburg State University. All the documents provided by the candidate for the degree, as far as I'm informed, comply with the requirements and are found in the certification file of the candidate for the degree. And the curator of the defense, member of the dissertation of the Department of Dissertation Board Support, has all the copies. And before I give the floor to our candidate for the degree, I need to ask a question. Distinguished members of the board, do you have any general questions to our candidate for the degree? Is there a need to consider the whole list of documents submitted by the candidate for the degree? No questions about that. Okay. Now I would like to give the floor to our candidate for the degree. Andrey, please, you have the floor. Distinguished colleagues, hello. Let me give you an overview of my thesis, of my doctoral thesis. My work is titled Interactions and Effects of Hydrodynamic Waves in Middle and Upper Atmosphere and their Impact on General Circulation. First of all, a short introduction. In the atmosphere, we periodically see waves and periodic fluctuations of all hydrodynamic fields. With the rise of altitude, these fluctuations, amplitudes are growing, and they're becoming, I beg your pardon, they're becoming the dominating form of movement in the upper atmosphere, and they transfer energy and momentum. Planetary waves are the important driving force of the atmospheric meridional circulation, which is, due to its global character, an important link of the dynamic interaction between different atmospheric processes, and above all, large-scale wave disturbances in the ionosphere also influence the propagation of waves causing amplitude and phase fluctuations of the radio signal. And currently, these waves are an important field of study due to the fact that they have an impact on the communication systems and navigation systems as well. And studying the orographic gravity waves and taking them into account during modeling still contains certain problems and gaps, and according to current estimates, the parameterization of orographic gravity waves is still an important factor of scattering between different models. And therefore, there's a need to elaborate more accurate schemes and their parameterization. And in this work, we concentrate on the study of Meridianal, mesoscale perturbations of orographic origin, and global atmospheric oscillations, planetary waves, the interactions and sensitivity in space-time structures to some impacts, external impacts, like quasi-biennial oscillation of a low-latitude zonal wind, sudden stratospheric warming events, and cyclical changes in solar activity. The second important goal is to study the reaction of the general circulation of the atmosphere, as well as the residual meridianal circulation, to the impact of these events. And the statements proposed for the defense are as follows. There are just 4 of them. They introduced model of general circulation and blocks of computer programs for the computation of thermal impact of orographic waves, allowed us to get new data on the interaction, on the effects of these waves on atmospheric circulation, taking into account such dynamic impacts like sudden stratospheric warming or QBO. The study of the mechanisms of dynamic interaction of various atmospheric layers due to the propagation of planetary waves using novel numerical algorithms for the computation of properties of the atmosphere, waveguide properties of the atmosphere, allowed us for the first time to obtain quantitative statistically significant impact estimates of the impact of OGW and other large-scale processes in the stratosphere, such as SSW and QBO, on the global circulation in the middle and upper atmosphere. And the hypothesis about the important role of reflected planetary waves in the transport of disturbances from the thermosphere to the stratosphere was confirmed, and we used the new methodology and consider different levels of solar activity, and we use new software, newly developed software for statistical processing of the model calculations, data processing. And the last article, a statement, modeling of the reaction of RMC to the thermal and dynamic effect of OGWs and planetary waves at different stages of QBO and SSW, using the algorithm and software package developed by the author. And it allowed us to get new data on residual circulation, reaction on the wave interactions. As for the main study technique, we use numerical modeling, and currently numerical modeling is the most efficient mechanism of study for different dynamic processes in mid and upper atmosphere, and it allows us to study their relative contribution to the hydrodynamic atmospheric mode. Thus, numerical modeling allows us to carry out idealized studies of certain processes without taking into account other processes that can add up some uncertainty during the consideration of results. And at that, the series of, or rather ensembles of modeled solutions allow us to increase the statistic significance. And in this work, I used a 3D nonlinear mechanistic general circulation model in the middle and upper atmosphere. And it is developed jointly by Russian Hydrometeorological University and St. Petersburg State University. And the major advantages of this model are that it's one of the mechanistic models that is capable to reproduce the events of major stratospheric warming, sudden stratospheric warming. And the model also allows to compute circulation of general atmospheric circulation up to altitudes of 300, 400 kilometers using numerical algorithms. Thus, we managed to eliminate different distortions that can be obtained in some compound models of upper and lower atmosphere, of mid and upper atmosphere. As for the testing and validity of the results, during the study, we use a new method of automated statistical processing of ensemble simulations that allows us to increase the efficiency of calculations significantly and statistical validity as well. And also the results of calculations are compared with databases or free analysis of information. We compare with empirical models of the atmosphere, with data of satellite observations, and also some ground observations data, like using ionized network, and we compare with modeling results of other models. So there were more than 30 reports delivered on the results of the study at Russian and international conferences, and over 26 articles were published in peer-reviewed journals, and more than 4 of them, currently 5 publications, are in first quartile, and 3 articles without co-authors. And the work within the framework of the dissertation was supported by 6 Russian scientific grants, and I was the head of the grant. And now let's discuss the results. First of all, let's consider the parameterization of horographic gravity waves. With the use of mesoscale wave theory in the rotating atmosphere, we define the polarization relations, and we obtained the following expressions for total wave energy transfer, for gravity wave drag, and inflows of heat. And we obtained an equation that describes the evolution of amplitude with altitude. And with a set amplitude at lower boundary, it can be solved with respect to the profiles of temperature and wind. And OGW temperature at lower border is found using the concept of subgrid aerography. And here the horizontal scale is less than 1 step of the grid. And the test calculations demonstrated 3 typical scenarios of penetration of horographic waves up. We see the waves formed over the mountainous regions that are able to penetrate up until heights 80-90 kilometers. And the waves that are formed in denser atmospheric layers have less vertical length, and they are prone to viscous damping, lower the height of 30 kilometers. And finally, The change of a direction of zonal wind creates barriers in the spread of orographic waves at altitudes where zonal wind approaches zero. And here to the left, you see the latitude-altitude distribution of zonal wind. You see the amplitudes of orographic waves, the increment of zonal wind due to the inclusion of parameterization of orographic waves, and the distribution of wind according to reanalysis data, MERA2. And these results were obtained based on ensemble calculations. And here it's important to mention that in the southern hemisphere the calculations were done for January. Therefore, in the southern hemisphere, where zonal wind is going, orographic waves spread, and in the northern hemisphere we see the spread. And for detailed consideration, we computed horizontal distributions of hydrodynamic parameters, and here to the right you see latitude, longitude distribution of zonal wind, increments of zonal wind, and amplitudes of orographic waves at the height of upper troposphere. And the characteristic point here is maximum amplitude of orographic waves that is observed over largest mountain ranges, mountain obstacles on the surface. Then we had a model that is capable to reproduce sudden stratospheric warming. Here on the slide, you see the examples of temporal ranges. Here to the left, you see mid-zonal temperature in a circumpolar area, and to the right, zonal wind at 62 degrees northern latitude. And here you see different types of warming. In the upper part, you see major sudden stratospheric warming with a turn of wind below 30 kilometers, and second line is high stratospheric warming, where inversion of wind is observed but does not reach the level of 30 kilometers. And below you see minor stratospheric warming without the turn of zonal wind, and the model run without warming. And based on such distributions for every model run within the framework of the ensemble, we define the dates of warming, and we create the composite, develop the warming composite. And this composite is relevant for climatology of sudden stratospheric warmings based on reanalysis calculations. And we choose 3 11-day intervals before, during, and after the sudden warming in order to consider the hydrodynamic fields at different stages. And here to the left, you see the distribution of zonal wind, deviation of temperature from average index of 2 months, and in the mid left image, you see the expected weakening of zonal wind during the warming, and you also see the warming of stratosphere itself on the central panel, and also you see the weakening of orographic waves connected with the fact that in separate regions of lower stratosphere, the inversion of zonal wind prevents the spread of waves to the upper direction. And here you see also the model computation during different phases of 2-year oscillations, of biennial oscillation. You see the January zonal wind, and to the left that's modeling, and to the right MERA2. And below you see the increment of zonal wind according to the data. And here you see that we not only have the expected radical change in the equator, explained by a quasi-biennial oscillation. We also have significant contribution of extratropical stratosphere. And above the comparison of zonal wind, we also carried out comparisons for meridional wind and temperature, according to the reanalysis data. And we detected good correlation, and the inclusion of orographic waves into parametrization allowed us to improve the correlation. And above all, the next stage of work is dedicated to planetary waves. MUM-AM model looks as follows. You see the spreading to the waves, to the west, planetary waves with periods from 4 to 11 days. They are added by additional terms in this thermal balance. And in order to interpret spatial temporal structures of planetary waves, we use the concept of wave guides that provides for calculation of refraction index squared. And planetary waves, according to the theory, spread inside the wave guides, where the refraction indicator is positive ones, and they damp beyond these areas. Second important point in the analysis of planetary waves is Alias and Palm flux. And here you see the formulas for calculation of these parameters. And using planetary waves, these flux, the direction of this flux is characterized by the direction of propagation of waves in meridional plane. And divergence of the flux is characterized by the acceleration of zonal wind eastward. Here on the slide, you see the modeled amplitudes of stationary planetary waves. On left panel, you see zonal numbers from 1 to 4, different stages of stratospheric warming. And if we consider upper panels, where you see SPW1, you see we see the increase of amplitude of planetary wave and its movement closer to the pole. And that is accompanied with the weakening of the zonal wind, of the considered zonal wind in the mesosphere. It's vice versa. We observe the increase of amplitude of the planetary wave. And to the right, you see amplitudes of stationary planetary waves, the same zonal numbers from 1 to 4 in eastern phase of QBO. And in the right column, you see the increment of amplitude due to the change in phase, western minus eastern. And the general trend is that amplitudes of planetary waves in western phase are weaker than in eastern phase, and that is accompanied by acceleration of circumpolar eddy. And these distributions were compared with distributions of stationary planetary waves. They were compared with reanalysis data, and in upper altitudes we considered these amplitudes of planetary waves according to broadband radiometry using the satellite data. And we found good correspondence of the modeled amplitudes of planetary waves to these observations. Next section is dedicated to the study of solar activity and the change of structure of planetary waves and atmospheric circulation at different levels of solar activity. And in the MOA model, the main indicator is the flow of radiation at a wave length of 10.7 centimeters that changes during the 11-year solar activity cycle. And various values of this flux corresponding to a maximum and minimum of solar activity were set in the model only for above 100 kilometers. Below 100 kilometers, we used a constant value of this flow, which corresponds to the average medium level of solar activity. And at heights upper 100 kilometers in the model, we set ionospheric conductivity, including latitudinal, longitudinal, and temporal variabilities that were calculated for different flux sizes. And such approach allowed us to isolate the impact of thermosphere and consider the thermospheric effects associated with the change of solar activity on the average atmosphere, on mid-atmosphere. And here you see the variations of geopotential heights with numbers from 1 to 4 in the range of heights from 0 to 300 kilometers to the left. And the leftist column, next column is increment of amplitudes of stationary planetary waves in change of solar activity. And the right two columns show us the similar data for the range from 0 to 100 kilometers. Stationary planetary waves are generated near the surface and they propagate up along the wave guides. And for considered season, January-February, they pass through northern hemisphere, upper stratosphere. The wave guide crosses the equator and goes to the southern hemisphere, and thus we see the propagation of planetary waves. And to the right, you see the increment of amplitudes of planetary waves, and mostly you see that the change in consideration of solar activity in thermosphere higher than 100 kilometers leads to the change of amplitudes of stationary planetary waves and these changes can reach 10%. And the major reason of such change is the reflection of the spreading planetary waves at the altitudes of lower thermosphere. And this can be traced according to the distribution of, for example, SPW1. We see that the weakening of amplitude in the mid-atmosphere is associated with the increase of amplitude in thermosphere, whereas for stationary planetary waves, with a zonal number 2, 3, 4, the trends are quite the opposite, and this means that stationary planetary waves with zonal number of 2, 3, 4 have more active reflection from thermosphere. And above stationary planetary waves, we also consider the structures of spreading westward planetary waves with different periods, and we considered zonal circulation. Here on the slides you see the distribution of zonal wind, temperature, meridional temperature gradients, and temperature according to empirical model NRLM SISE 0. And to the left, you see the range up until 300 kilometers, and to the right, up until 100 kilometers. And if we consider the changes of zonal circulation in thermosphere, then we can see that the major contribution into the change of speed of zonal wind is done by meridional thermal gradients, shown here on panel C. And according to thermal wind theory, in winter hemisphere, the weakening of temperature gradient corresponds to acceleration of zonal wind aimed westward. And we see such areas. And the panel to the right, in the right panel, we see the effect that is added, that adds changes into the fields of thermosphere to mid-atmosphere. And these changes can also reach 10%, which is a significant contribution. And the last section of the thesis is dedicated to residual meridional circulation. The concept of residual meridional circulation within the framework of Eulerian mean average was proposed in order to diagnose wave impact on mid-flow. And it represents a superposition of vortex and advective transfer. And here you see the formulas for the computation of vertical and meridional components of the residual circulation. And based on these formulas, we devised a software package to compute residual circulation based on ensemble computation models. And here to the left, you see the distribution of residual meridional circulation according to modeling data and according to Meridianal data. To the right, you see the latitudinal, altitudinal distribution, then meridional component, and below you see the vertical component. And in mid panels, you see residual circulation, and to the right, you see the vortex input, the eddy input. And we see that maximum values of this eddy component are observed in the northern hemisphere near the propagation of the already considered planetary waves. And above all, the residual circulation was considered at different stages of sudden stratospheric warming. We considered orographic waves on the structure of residual circulation, and we also considered the impact of the phase of quasi-biennial oscillation. And for example, we can see here that there is a strengthening of downward component of residual circulation in circumpolar region during sudden stratospheric warming that promotes additional heating of stratosphere during the warming process. And as for conclusion, the use of modeling to simulate different wave processes and their interaction allowed us to selectively investigate these processes in order to understand their mechanisms better. And as for the main results, they are as follows. A new block of computer programs has been developed for calculating the dynamic and thermal effects of OGW, and it allows us to carry out calculations and the inclusion of this block into the model allowed us to get a range of new data on the effects of these waves during different impacts. And this, with the help of new blocks of computer programs with high degree of statistical reliability, for the first time with such reliability, it was demonstrated how the effects of orographic waves and quasi-biennial oscillation and sudden stratospheric warming lead to changes in the structure of planetary waves. And at the same time, these planetary waves spreading to other latitudes and altitudes promote the spread of these initially localized effects to other layers and atmospheric areas. The novel results obtained regarding the thermosphere impact of solar activity and changes in general circulation in the atmosphere. So these results were obtained, and using the developed software for the calculation of residual meridional circulation, we studied the sensitivity of structures of residual meridional circulation to different wave processes, like quasi-biennial oscillation, sudden stratospheric warming. That's it. Thank you so much. Thank you, Andrey. Now, according to our agenda, the members of the board and everyone present here may ask questions on the thesis, if there are any questions. Yes, please. May I? I have a small question on the instruments that you had dealing with the use of the model for calculations. There is an opinion that a real upper border in model calculations, where you compute the fields, it should be much higher than the level at which the obtained results are considered credible. So higher to the upper level physical level, the results that the model gives can be dubious. And here you showed in your report several results when you mentioned the impact of solar activity that you got for the height of 300 kilometers, and at the same time you say that the model allows to model dynamic processes up until 300-400 kilometers. So, shortly forming my question, have you observed such effects as maybe uncredibility of the obtained results in the upper border of your model? Well, first of all, I need to explain why 300-400 kilometers. Yeah, please. Because in the model, we use isobaric coordinate. Therefore, geometrical height depends on the temperature. Therefore, it can fluctuate. Thus, we get either 300 or 400 kilometers. And as for whether there are any distortions dealing with the upper border of the model, we observed none for those heights that we considered. The structures of residual circulation, or the circulation itself, or wave processes, we had an opportunity to compare our data with the accessible data for comparison, and there were no deviations, no distortions at the upper limit. Okay, thank you. Other questions, if any, on the report of the candidate for the degree? None. Okay, thank you. I have a question. Yes, please. Yes, please. The thesis and the speech you mentioned a lot about the impact of wave movement on the dynamics of the atmosphere. And what's the impact on the energy? In particular, when you compared radiation impact and other,
относительный вклад
What's the relative contribution on energy? Well, it's quite simple. I dwelled upon it partially.
А по-русски можно услышать?
Can I listen to the Russian channel? Yurian, what language am I speaking? So they considered we consider Alsenpalm fluxes, and according to their formulas, the general trend is as follows: that targeted up, the component that is targeted up, it is accompanied with flows of heat that are directed at the pole. Therefore, the increase of wave activity and the increase of flows that are going up, it promotes the change of temperature in circumpolar region. So that is one of such factors that we have for the energy. Thank you. No other questions? Yes? Okay. Yes, I see none. Okay. Now, we are to listen to the members of the board with their reviews. With the overviews of on the thesis. And I offer the candidate to answer the questions after each of the reviews, just to save some time. Okay, first of all, I wanted to learn whether we have some external reviews. None. Okay. Now, I would like to give the floor to our members of the board. And let us start with Vladimir Kosov. Well, I believe there's no need to read the entire review because there are 4 pages here and a lot of places dedicated to the description, to the descriptions. Yes, all the reviews were already published on the website, therefore you can, yes, therefore I can say just a few words. I just wanted to mention that the thesis is dwelling upon a broad topic of the study of wave processes in the Earth atmosphere, and it is dedicated to the issues of numerical modeling of atmospheric fluctuations of different scale, and to the study of interactions between them and the analysis of sensitivity of wave processes to different external influences. And I believe that this work is quite relevant, sure enough, because parameterization of wave processes in the models of general circulation is a significant source of uncertainty during modeling of atmospheric circulation. And the significance of this work is also quite obvious because many issues of interaction of different atmospheric fluctuations up until now were not finally studied. And I would like to emphasize that this thesis is a result of many years of studies of Andrey Koval. And these studies were aimed at the solution of several important problems. So overall, I liked the work, and now then in my review I list the goals that the author achieved, and then I believe I'll read my comments and remarks. The first remark is as follows. In section 2.5, dedicated to the influence of horographic gravitation waves on average meridional circulation and flows of atmosphere in the of ozone in the atmosphere, the author says that his calculations for ozone for high altitudes higher than 30 kilometers are rather an appraisal because they don't take into account the short lifetime of ozone at this altitude. So there's a question. If you model general circulation of atmospheric components, and there is this inadequacy in description of processes, at some extended area of altitudes. So are these results valid for altitudes lower than 30 kilometers where the lifetime of ozone is high? I believe I'll read all the remarks at once. Yes, how? What's more convenient for you? You can read all your comments and then I'll answer. Okay. Yes, there are not many of them. Okay, second remark. In section 4.2, the author emphasizes that he made an emphasis on thermosphere when studying solar activity impact. Therefore, the F10.7 flux in thermosphere was selected differently, whereas below 100 kilometers it was permanent. And the author says that it was done to isolate the influence of thermosphere, and this argument is not quite obvious for me, and it requires further explanation, I believe. What's the aim of this isolation? And third important remark is dealing with the discussion of partial reflection of planetary waves at altitudes of lower thermosphere. The author says a different reflection of planetary waves can promote the change of proportions of wave energy of planetary waves penetrating into thermosphere and the change of amplitudes of planetary waves in thermosphere and in mid-atmosphere. However, out of this text of section 4 and links to these works, there's an impression that this result is not a novel one and is more of a qualitative character. So there's a question, what are the quantitative characteristics of the effect of partial reflection of planetary waves as such were obtained using the model? Then I had two insignificant comments that are dealing with certain stylistical flows and misprints and the quality of several images. And that's basically it. That's basically it. And once... I wanted also to say that these are not some key remarks, and they did not compromise the overall very high value of this dissertation, because initially I said that I like the work a lot and I believe that it's significant, and that's a significant contribution. So that's it. That's it from my side. Thank you so much. So let's go step by step. The first question on ozone. Our model that we used, it does not have photochemical block, therefore taking into account the lifetime of ozone, which is lower than 30 kilometers, which below 30 kilometers it exceeds the time of dynamic flow on our temporal intervals. On these altitudes, it gives us some good values of the flows. And as for altitudes higher than 30 kilometers, there you have to take into account the photochemical processes. And therefore, our data is a bit distorted. However, overall, taking into account the fact that the volume of ozone upper than 30 kilometers is larger than, and then below, these flows can't give us significant contribution to the general circulation below 30 kilometers. Second question about the isolation of thermospheric processes. Our main goal was to register the impact on the mid-atmosphere that comes from thermosphere. To this end, we needed to exclude direct influence of the change of solar activity, solar radiation at different levels of solar activity, and that's impossible for the analysis of data, and model calculations allow us to use this approach. And the next question. Next question. On the reflection of planetary waves. and that the results are more of a qualitative character. Yes, here we can see that indeed we had works in which we provided for the presence of such a mechanism, yet in the previous works it had more of a qualitative character of this hypothesis. And we, using this isolation approach of thermospheric changes, we managed to obtain qualitative assessments of the change of circulation in mid-atmosphere and of amplitudes of planetary waves using this particular effect. And that's one of the novelties of the work. Yes, and as for some significant remarks, yes, I agree with them. Indeed, the quality of some of the pictures is not sufficient because the file was compressed a lot to download it to the website. Therefore, that was this problem. Thank you. Okay. Now I would like to give the floor to Professor Polyakov. As Vladimir, I won't dwell upon the detailed description of the work. I just wanted to mention that I just wanted to mention the use of model that allowed the author to avoid the problems of joining of different models, different atmospheric layers. And this middle and upper atmosphere model allowed him to get quite interesting results using these advantages. And above all, I would like to mention the original parameterization of horographic waves that he included in the middle and upper atmosphere model that allowed us to see interesting results and to show the importance of the impact of horographic waves up until the heights of a lower thermosphere. And still there are certain flaws in the work, but I believe that's quite frequent when you have some style or punctuation flows. Not all the colors are chosen correctly. Maybe it makes these images uneligible. And in chapter 4, the comparison of planetary waves in thermosphere with data of aerosons are done in 3 points, and to our mind this does not allow us to make a substantiated conclusion on the correctness of modeling. And there are some terminology inaccuracies. I believe I won't mention them. That's clear. And these remarks do not compromise the overall high value of the thesis and do not compromise the achievements. Therefore, certainly I believe that this work is performed at a very high level, and our candidate deserves the doctoral degree. Thank you, Alexander. As for insignificant style remarks, yes, I'll bear them in mind for the future. And as for the comparison with ionizant data, there's not much data here, and we used what we had at hand. And on the results presented, we see that the model is quite satisfying in reproducing the major fluctuations of planetary scale with periods from 4 to 16 days. And above all, we carried out comparisons with satellite data at those heights and temporal regions where it was possible. And later on, I believe we'll continue developing this field, take into account the longitudinal network of ionozones, based on which you can establish more specific fields of fluctuations of planetary parameters. That's it. Thank you. Thank you so much. Now I would like to give the floor to Professor Christoph Jacobi. Professor, can you please comment on the work of Alexei Koval? What's your opinion about this work?
So I'm quite sorry that I didn't understand this Russian.
Не надо повторить? Ну хорошо.
Do I need to repeat?
So I should give some summary of my report right now.
Да, yes.
Yes, the summary of your report, please.
Yes, we are waiting for your summary for this report.
Okay, thanks. So, I report on this thesis that's dedicated to the analysis of waves in the upper atmosphere and propagation and the interaction of each other and the mean flow. And it's only a summary, so I think that maybe I have to say that Koval uses the global numerical model. So in the model with new developments and some new modifications required for the investigations, and with some validations by literature results and analysis of the thesis has 5 chapters, and it concludes. The chapter is a review of the relevant literature and the scale of planetary waves in the atmosphere and the spectrum of Residual. Also, the Muam general atmospheric circulation model is described comprehensively, including the systematic core and the parameterizations and detailed numerics. So, chapter 2 is dedicated to the detection of Horographic waves. And there's a new parameterization of Horographic wave formation, interaction is described and tested, and again a very comprehensive analysis the effect of circulation patterns such as hydrosphere. So the next chapter includes the numerical modeling of planetary waves.
Professor Jacob, sorry. Professor Jacobi, due to technical problem, we have to stop your report. Please wait for some minutes, and then we can continue once more. Sorry for stopping. No, wait for some minutes because we don't see, we don't listen to Russian language of your speech.
Professor, there's a technical break. Do I get it right that you simultaneously hear a translation during your speech?
Should I continue? So there's an effect of 11 years to the cycle of solar activity on planetary wave activity in the atmosphere is analyzed, and the solar activity is prescribed or modified in the atmosphere. I think it's interesting that there's presented effects on the middle atmosphere due to the current.
Коллеги, я должен сделать технический.
Distinguished colleagues, I need to announce the technical break number 2. Professor, do you hear us?
analysis, particularly with respect to their comprehensive nature and statistical value. And this analysis, as the dynamics of the middle atmosphere, particular cupping processes, are key to understand their success.
Excuse me, Christoph, one moment, Christoph.
Highly important at this time and necessary for investigation of the cupping of the
Потом ему повторять.
Professor, do you hear us? Christoph, do you hear us?
The thesis is, although it contains a lot of different approaches and different topics,
Christoph, do you hear us?
it's a very, very important step towards our understanding of the atmosphere. And
interrupt your talk, your summary, because we don't listen to Russian language, our translator. So I'm afraid that you have to repeat your speech once more, maybe not so long time, maybe 2 or 3 minutes, just only summary. We have a technical problem. Please wait for a moment. Ой, не слышно.
1, 2, 3. Checking the sound, English channel.
Работает?
Работает. Работает. Работает.
Christoph, did you hear the sound check?
Yes, I did.
Oh, okay, okay. Christoph, could you just say a few words right now? Just a few words, so that we would check the translation.
Yeah, I can do that. Do you hear me now? Is this... So, can you understand me?
Distinguished colleagues, our technical break number 2 is finally over, and we resume work. I have a question to Christopher. Christopher, unfortunately, we'll need to ask you to voice your conclusions once again on the thesis of Andrey Koval. Please be quite short and just make us a 5-minute summary.
Okay, no, it could be even shorter. So it was a thesis on middle and upper atmosphere modeling with new results, with new methods to be applied, with interesting results concerning the coupling of the middle atmosphere and the upper atmosphere, and it is based on work which is published in quite a considerable number of publications. The research what has been done is interesting, it is important, it's timely at the moment, and these results are urgently needed because the middle and the upper atmosphere in particular will become more and more important in climate modeling. So I'm very positive about this thesis, and I recommend to accept this as a thesis for the granting of the doctoral grade. So that is in very short.
Okay. Спасибо.
Thank you so much. Now we can give the floor to our other participants, and now I would like to give the floor to Ivan Karpov. Ivan Viktorovich, do you hear us? Ivan, please turn on the microphone. Yes, I finally did. Do you hear me? Yes, now we do. Okay, please give us your comments on the thesis. Well, basically, I don't want to take too much time for this discussion. I strongly believe that this thesis is quite a good one. It characterizes our candidate very well because that's a huge volume of model and numerical experiments, and it has a particular importance for the understanding of interaction between mid and upper atmosphere, and I believe there's no need to list all the real achievements that our author managed to make. But for me, particularly, I see that methodology of description of upper and mid atmosphere is a very important aspect that our author managed to describe. I don't have any significant comments, but I have some wishes. The thing is that when we describe upper and mid atmosphere, basically speaking, in contemporary conditions, in practice, upper atmosphere is described as in self-congruent dynamics of components. Why so? Because the effects that can influence directly on ionized components have the same characteristic scale. So here I'm referring to planetary waves. And therefore, these effects from the bottom and up should be taken into account, but that's just a wish, and I believe that's a natural way of the development of mid and upper atmosphere that the author uses. So that's basically it, what I wanted to say. Thank you so much. Ivan? Yes, please, Andrey. Thank you so much for the wishes. Thank you so much for your opinion, Ivan. As for taking this process into account, the ones that you've mentioned on the heights of thermosphere, on the altitudes of thermosphere, overall, we should take them into account for more correct replication of planetary waves, the heights of thermosphere. But basically, in this case, our goal was to study just that spectrum of planetary waves that comes from the lower atmosphere. And we concentrated our attention on that. Thank you so much. Thank you so much. Okay, thank you. And now I would like to give the floor to Alexei Krivolytsky. Please, Alexei, your opinion. Yes, okay. I'll read some parts of the text that I've given. So the thesis is dedicated to the study of an important problem, non-linear interaction of waves of different scale and the impact on the dynamic and thermal regime of the upper and mid-atmosphere. The relevance of the study is associated with the need for an in-depth understanding of wave processes and the impact on the climate change and other processes. It should be mentioned that this topic has long been in development because this issue is directly associated with weather forecast preparation. And here we can not but mention the work of Rossby. The works of Rossby, who saw these waves on synoptic maps and assessed their length. Since then, the weather forecast was aimed at the use, at the opportunity to use these waves in the forecast preparation. So thus the work is quite relevant. However, the data that we got within the recent 50 years, especially in the most recent years, they gave us new tasks, and these models of such a level allowed to resolve these problems. For troposphere, not just for troposphere, but also for other areas. Internal gravitation waves are now getting a lot of attention because in troposphere, the impact is negligible, but somewhere in mesosphere or in thermosphere, they play a key role because the density drops and the amplitudes are growing. And the interaction of these waves with mean flow gave a lot of fields for further study. So the goal is quite relevant, and the models that allow to resolve these problems are quite important. As for the achievements of the author, I should mention the development of methods of ensemble model calculations that allow to assess the necessary model runs. And that's the technical point, which is quite important. The work managed to obtain novel results of changes of aerographic waves, planetary waves, and parameters and general circulation in the atmosphere in different phases of dynamic processes, including the reaction to stratospheric warming, quasi-biennial oscillations, and all the results of the thesis are statistically valid, and all the results comply with the observations that we already have, and they all are quite novel. The work is performed at a high scientific level, and I wanted to mention the logic, very clear-cut logic of narrative, but there are certain drawbacks. For example, there is lack of sufficient consideration of the structure of horographic waves. In section 2.3, there are vertical profiles of parameters of horographic gravity waves in 2 geographic points. And in other chapters, you give mid-zone amplitudes, and it would be useful to consider the structure of over this heterogeneous relief, for example, according to a latitudinal circle. When you compute statistical validity, statistical importance, the method that you use in section 1.5, you use paired student t-test that allows to work with data sequences that can be pairwise correlated to each other. And the differences in 9 neighboring nodes can be correlated, and the question is, did you check it? And the author says that one of the most outstanding novel results are the new algorithms and software packages for the calculation of waveguide characteristics of the atmosphere. And the question is, what is essential and new in these algorithms? Maybe it would be better to give the results of computations using these algorithms. What do they give? However, all these remarks do not compromise the overall high value of the work, and the combination of the results of the author can be considered as a significant scientific contribution to the solution of problem of solving of wave interactions, the waves that are capable to influence the dynamic regimes in the atmosphere. And the author published 33 articles, and out of them 24 were, there were 20 articles published in journals that are indexed in Web of Science and Scopus, including first and second quartile journals. The results were delivered at more than 30 international conferences and symposia, given in the introduction. And the importance of the study is supported by the fact that they are supported by the Russian Foundation for Basic Research Funds, as well as by many other funds. Thus, the author deserves the degree of Doctor of Sciences in Physics and Mathematics and specialization 250029, Atmosphere and Hydrosphere Physics. Thank you. Thank you so much. So, Andrey, please, you can answer. Yes, thank you so much, Alexei. As for the consideration of aerographic wave effects, I rather see that as a wish for the future. And indeed, it would be very interesting to see the latitudinal, altitudinal distributions on certain isolated mountain ranges. And it would be nice to see the temporal variability. I believe we will continue our the development of our parametrization in this field. As for calculation methods of statistical importance, indeed, we check the correlation between the neighboring sets. Somewhere we had 0.7, but still, in our student formulas, for 9 times we reduced the number of degrees of freedom, and this had practically no impact on the result. As for the correlation of continuous temporal series, or the correlations between ensemble calculations, certainly naturally they exist because they reflect the peculiarities of the spread of hydrodynamic values for a specific season. Just a moment. I'll check other comments. And as for the wording, here certainly you are right, because it would be better to outline new results rather than new algorithms, because the approach to calculation of statistical importance is based on standard criteria. And that's student t-test. And the value of the developed algorithms is in the operational treatment of big data of ensemble calculations that increase the speed of calculations and study. Thank you so much once again for the comments. Okay. Thank you. Our next member of the board is Nikolai Pertsev. So please, your conclusion. So, turn on my microphone. Yes, we do hear you. Well, as the previous speakers, I'll dwell upon the content and the important part of my review. First of all, my positive remarks. Regardless of some thematic mosaic of this multifaceted topic of wave interactions in mid-atmosphere, author still managed to cover the key narrow topics that gave us the finished study with internal logical connections between the chapters. Second point. Quite valuable are the conclusions in this part of the thesis that considers the interaction of heterogeneity of relief with waves in the atmosphere, and the results that show significant impact were received using the modeling technique, and their value is quite high, though they cannot be directly checked by nature studies, because in nature it is impossible to turn off heterogeneity of the relief. Third point. The conclusions are quite logical and quite well substantiated. Just as an example, on page 152 you give additional study on the contribution of planetary waves generated by the model without the participation of orographic waves. And above all, the results are well tested on for sensitivity to many impact factors like change of the level of solar activity, phase of quasi-biennial oscillation and sudden stratospheric warming. The author also gives details on validation of the model that the author uses. The fourth point, the comparison of hydrodynamic fields with reanalysis data proves that the model is able to correctly reproduce atmospheric circulation, including such events as quasi-biennial oscillation and altitudinal processes in the atmosphere. And now a few words about the drawbacks. First of all, in the thesis, in several places, you write that results achieved due to meridional circulation demonstrate a significant mass transfer and redistribution of mass between hemispheres, but there were no assessments of this redistribution. Second point. Well, that's not a mistake, but rather some incorrect emphasis in the interpretation. That's what I'm talking about. Analyzing the results of statistical approach to the values of horographic increments of speed velocity, you write it a bit negligently that at high altitudes in summer hemisphere these increments are small and not statistically reliable. Here I would like to mention that this statistical unreliability can deal only with mid-averaged values, because significant variability in generation and propagation of orographic gravity waves should lead to significant changes in velocity. That includes high deviations from average values, and these deviations are quite important for the statistical ensemble that you get. And finally, there are several remarks on the technical jargon and the use of terms. I believe I won't dwell upon them. And basically, the thesis gave me a very good impression, and it meets all the requirements that we usually have for doctoral dissertations, and I can recommend this dissertation for defense and for the award of the academic degree. That's it. Thank you, Nikolai Nikolaevich. Yes, thank you so much for the remarks. I'll go step by step. As for meridional mass transfer, it was mentioned, it was not mentioned in detail. Simultaneously, we conducted calculations for meridional mass flows, and we registered significant variability during sudden stratospheric warming. And as of today, an article was published about that, but it was not included in the article list on the thesis. As for the interpretation of data of longitudinal, latitudinal distributions, increments of hydrodynamic parameters, yes, indeed, we've computed the statistics based on ensemble calculations and averaging, and certainly it really smooths out the distribution. However, in order to take everything into account, the basic main trends that emerge with heterogeneities around orographic waves, well, we needed to use ensemble calculations. And indeed, it should be mentioned that we can consider separate strong perturbations that can emerge at certain periods of time during certain runs. But once again, yes, that's a task for the future, quite a large one. And as for the remarks on the use of technical jargon, yes, it's mostly associated with the fact that some of the terms were taken from English literature and they have no similar terms in the Russian language. So thank you so much for pointing out those points where the term was not quite accurate. So thank you so much for the remarks. Okay, thank you. Sergei Soldatenko, here's your review. Yes, thank you. Distinguished colleagues, distinguished members of the board, you see, when assessing the thesis, I can't divide the thesis from the author. As for the thesis, formally everything is okay, and there are no questions about it. As for the author, you know, I've met him several times, and during his study, I met him as well, and you know, I had a very good impression in all regards, as a scientist, as a person, and I believe that the thesis is certainly deserves a very good mark, and here I would like to say that our author is also a great man, because during these hard times he managed to choose such a complicated way, and I support him and I will support his further work in future. Therefore, I wish him all the success in his future work, and I'll vote for the award of the academic degree. Thank you. Thank you, Sergei. I believe that there are no comments here, and there's no need to answer that. If only the author wants to add something. Yes, I'm grateful to Sergei Anatolyevich for such a positive opinion about me and about my work. Thank you. Okay. Yuri, Professor Timofeev, please, you have the floor. Well, I'll also be quite brief, because we start repeating each other, and I'll dwell upon the principal comments. In the thesis, it would be nice to assess not just the dynamics, but also the energy, maybe compare with other mechanisms. The second remark, I don't doubt that the model of general circulation that Andrey used is validated quite well and quite accurately. And the comparison of new facts, it is quite hard, but it would be nice to compare the fresh results with the old ones. And there are a lot of experimental data right now, satellite data as well. Maybe they are not always suitable for comparison, but maybe in future you can work on that issue as well. And talking generally, and switching to the conclusion, I want to say that that's really immense work on an important topic, and the author got new original results. The work is prepared at state-of-the-art level, and so he published his works in very good journals, and a practical value of the results can be indirectly seen from the fact that today Andrey is responsible, head of a new mega grant that the university got, and on the one hand it emphasizes the importance of the topic that he's working with, and also it emphasizes the attitude, good attitude to Andrey among the scientists in the sector. Therefore, the main conclusion is as follows: the dissertation fully meets the requirements of the appropriate document, and Andrey Koval certainly deserves the academic degree of Doctor of Sciences in Physics and Mathematics in appropriate specialization. Thank you so much. Thank you, Yuri. Andrey, your comment about that? Yes, thank you so much, Yuri, for the opinion and for the remarks. Indeed, in all aspects considered, we have a lot of options for further studies. We can consider the energy of the processes in detail. The same is true for the problems of comparison. And in the upper atmosphere, we don't have a lot of data that can be compared directly with modeling data. And as a result, every time you have a comparison in every separate moment of time in any specific point. And it's, hard to establish climatology here. However, we plan to expand this field further on to validate comparison models, to validate the comparison of new results with observations data. Thank you so much for the comment. Thank you. And now the review of the head of the board. I also mentioned specific proposals. Well, the thesis is dedicated to the numerical modeling of large-scale atmospheric fluctuations and mesoscale perturbations of orographic origin in mid and upper atmosphere. Major attention is given to the analysis and interpretation of wave interactions and the sensitivity of space and temporal structures to auto impact as quasi-biennial oscillation, sudden stratospheric warming, and the changes in solar activity. The author got important novel results. He developed a new software program that includes parameterization of dynamic and heat impact of orographic gravitation waves on the atmospheric circulation. Wave guide characteristics were calculated up until the thermosphere heights, and he calculated residual meridional circulation according to model data, as well as the flows of conservative atmospheric impurities. The work is performed at a high scientific level. Still, there's a range of comments, and I won't dwell upon them because some of them were already mentioned, in particular the comment on ozone flows. But the first remark, as for scientific novelty, you give it that the inclusion of OGW parameters into your model improves the correlation of modeled and observed circulation. However, you don't give the accurate data how much how much did you measure that? And yet another point that I wanted to mention is that in the western phase of quasi-biennial oscillations in stratosphere, stationary planetary waves are moving closer to the pole. And on image on figure 2.7, we see that they are bending to equator, and this leads to the strengthening of zonal flow in high latitude stratosphere. I won't give you some insignificant flows, but the major conclusion is that these remarks do not compromise the overall high value of the work, that really makes a good contribution to the understanding of the problem. And the thesis by Andrey Koval meets the requirements established by the university. And Andrey Koval deserves the academic degree of Doctor of Sciences in Physics and Mathematics in specialization atmosphere and hydrosphere physics. That's it. Thank you. Thank you so much, Evgeny Fedorovich, for your opinion and for your remarks. The question that was dealing with the improvement of modeled fields due to the inclusion of orographic waves. We calculated the correlation coefficient for mid-zone average monthly distribution of temperature between the data of modeling and the data of reanalysis of UK Met Office and MERA 2. And if the correlation between the reanalysis data made up 0.99, then the correlation between modeling and reanalysis data made up 0.96 without without orographic waves, and it became 0.97 with them. And as for the direction of amplitude bending for stationary planetary waves, indeed, and that's a good point. I believe it's a misprint, because on the image you see the directly opposite effect. Okay. So all the reports were already read, and now I am to ask one question to the members of the board. Is everyone satisfied with the answers of Andrey Vladislavovich? Dear colleagues, your comment about that? Yes, I am. I am as well. Yes. Yes, I am. Okay. Yes, me too. Okay, I heard no other opinions. So, according to our agenda, the guests of the defense can also take the floor if they're willing. No one? Okay. Now, we would like to listen to the academic consultant, Nikolai Gavrilov, about the work of the candidate for the degree. Well, I'm really pleased that this long road is finally approaching the end. And we've been working with Andrey for more than 20 years already. He was our student, then PhD student. Then he passed all the stages. Now he's a senior researcher. And thus I had an opportunity to trace all his academic way, all his academic development. And at the initial stages, it was quite hard for him. Serious journals did not receive his articles, believing that they don't have sufficient quality, but still he continued to work, improved his model, and finally these works were recognized, and now they are printed in very respected journals. What should be mentioned here as well is that understanding the impact, the different influences require numerous runs of the model. One run is not enough. And it also requires the use of statistic approach. And here one of the achievements of the author is the development of methodology and software programs for such statistic averaging of the results and checking their reliability. And this allowed to study a broad range of issues on the wave interactions at different altitudes. And in particular, one of the most interesting results is, to my mind, is the conclusion that the change of temperature and wind in thermosphere that happen under the impact of solar energy, solar activity, they can influence the reflection of planetary waves and thus influence mid-atmosphere. And basically speaking, the issue of solar activity impact on lower and mid-atmospheric layers is now under discussion. And there are a lot of unreliable conclusions here. However, the author managed to obtain statistically valid results that confirm the fact that this mechanism can really work. And I believe that this thesis meets all the requirements. Requirements for doctoral dissertations, and I believe that Andrey Koval deserves the academic degree of Doctor of Sciences in Physics and Mathematics. Okay, thank you so much, Nikolai. Dear colleagues, is anyone willing to say something out of the members of the board or out of those people who are present at the session? No one. Okay. Did we get any additional questions from online broadcasting? No. Okay. Here we stop the discussion and we no longer take questions. And now, before we draw conclusions, I need to ask the members of the board and the candidate for the degree if there are any remarks or questions regarding the procedure of the session, maybe the ones associated with online access. And I solicit all of your opinions on that. No. No comments about that. None. Okay. Okay, thank you, colleagues. And now we switch to the vote. Now it's 5:30 Moscow time. Distinguished colleagues, we have an opportunity to hold a closed session to discuss the results of the defense. If there is no need for that, we can start the voting straight away. Let's start the vote. Oh, yes, let's start. Let's vote already. Yes, no other opinions about that. Okay. Therefore, I raise a question on the award of the academic degree of Doctor of Sciences in Physics and Mathematics in specialization 250029, Atmosphere and Hydrosphere Physics, to Andrey Koval. And now we are going to have an open vote. Let me remind you that the decision of the Dissertation Board on conferring the academic degree is positive, provided more than 50% of the board members, no less than 5 people, voted in favor. So please, Vladimir Kostov. I vote for the award of the academic degree to Andrey Koval.
I vote for the degree to Andrey Koval.
Professor Polyakov. Yes, I also vote for the award of the academic degree. Professor Jacobi, what's your opinion?
I vote for granting the degree to Andrey Koval.
Okay, thank you.
Ivan Karpov. Yes, I also vote for the award of the academic degree. Alexei Krivolutsky, what's your opinion? I also vote for the award of the academic degree to Andrey Koval. Okay, Nikolai Pertsov, what's your opinion? I also vote for the award of the academic degree to Andrey Koval. Thank you. Sergei Soldatenko. I also vote for the award of the academic degree, and I wish for the success to Andrey Koval. Yuri Timofeev, what's your opinion? Yes, I also vote for the award of the academic degree. Okay, in my opinion, I also vote for. Thus, distinguished colleagues, I would like to announce that out of the 9 participants who took part in the voting procedure, out of the 9 board members, 9 people voted for the award of the academic degree to Andrey Koval. No one voted against it, and no one abstained from the vote. Therefore, we decide to award the academic degree of Doctor of Sciences in Physics and Mathematics in specialization 250029 Atmosphere and Hydrosphere Physics to Andrey Koval. Dear colleagues, as our session was partially organized online, I would like to ask the members of the board or the Andrey if there are any questions on the procedure of our session. So I would like to ask you about that. No comment, none, no. No comments, no. Okay, thank you. Now I finally give the floor to Andrey Koval. Thank you so much, distinguished colleagues. For me, it was an honor to present the results of my work for such a representative board. And on my behalf, I would like to say that our community of atmospheric dynamic scientists is quite small, and therefore it's more pleasant to know your colleagues personally. And I would also like to say that I'm open for dialogue and for different proposals. Now you know where to search for me if you need any support or any help, or maybe joint participation in some projects. I'm always happy to participate, and I hope that we'll have fruitful cooperation in the future. And I would like to particularly thank my academic advisor and my thesis supervisor, Andrey Mikhailovich Gavrilov. For all these years, I'm trying to learn this knowledge that he shares with me, and he was always ready to support me during hard times. And thanks to his personal attitude, I did not leave this. I stayed in science. Therefore, I'm very grateful for that. And I would also like to thank Alexander Pogoreltsev. Unfortunately, he did not manage to join us today. Still, his desire to help and his active support and his active position in general really helped me a lot, and I'm sure that he'll get well and join us. And once again, thank you so much, everyone, for the trust that you've given me. I understand that you are all very busy. You're all renowned scientists, and the more important it is for me that you've participated in this process, regardless of all these technical failures that we had today. So I'm really grateful to every one of you. Thank you so much. Thank you, and we congratulate Andrey with the award of the academic degree. And we thank all the members of the board for taking part in this defense procedure. And I therefore close our session, and I thank all the participants for taking part in it. Please turn off the broadcast.